Hi everyone. I'm going to be going over question number 26 from the Chapter 8 Bingo Problems. This problem is really interesting. It has to deal with nuclear fission. So it says, let me read the problem really quick. It says an atomic nucleus suddenly bursts apart into two pieces. Piece A of mass ma travels off to the left with speed v sub a. Piece B of mass m sub b travels off to the right with speed v sub b. Then it says part A says use conservation of momentum to solve for v sub b in terms of m sub a, m sub b, and v sub a. And then part B, they want you to use the results of part A to show that k sub a over k sub b equals m sub b over m sub a. So we'll start with part A, which is right here. So use conservation of momentum to solve for v sub b in terms of m sub a, m sub b, v sub a. That's a lot to say. So let's get into it. So we know from just the very basics of conservation of momentum that P I, so the initial, equals Pf. So the momentum is conserved. So it's going to be the same before and after. When we look at before, we know since it's fission that this nucleus is just hanging out. There's no momentum that we're going to worry about. So we end up getting P sub I, or the initial momentum, equals 0. And then the final, let's split that up right now into the parts. Because we know the momentum is the mass times the velocity. And since we have two pieces, we need to add those together to find the total momentum. So let's say that piece A, we'll do that first. So it's going to be m sub a times v sub a. So that's going to be the momentum of piece A plus m sub b times v sub b. But something else we know, and I already wrote it up here, is that the velocity of A is going to the left, is what the problem said. And so we need to make that negative. I always like the left to be the negative direction. It's just, since I read left to right, it just makes sense to me that the right is always positive. So we'll put a negative right here in front of the momentum for piece A. So now we have this. Now all we need to do is solve for v sub b, which is right here. So we subtract over this negative, so we end up getting m sub a times v sub a equals m sub b v sub b. Now we just divide over the m sub b, and we get v sub b. So part A is done, really. So I'll just write this out a little nicer because we're going to need to use this in part B. So I'll erase this, give us some more room to work with. So we got v sub b is equal to m sub a v sub a over m sub b. So now, for part B, it says use the results from part A to show that Ka over Kb, so K sub A over K sub B, is equal to Mb, or M sub B over M sub A, okay, so that's what it wants to know. I'll write these over here. So K, A, K, All right. So the way we're going to do this one is we know that kinetic energy is 1/2 mv squared. And so K sub A is just going to equal 1/2 m sub A v sub A squared. And similarly, we know that K sub B is equal to 1/2 m sub B v sub B squared. Now, what we can do is, since we know from part A that v sub B is equal to all of this, we can plug that in and that way get rid of the v sub B variable. So let's just do that right here. We'll just erase it. So we end up getting m sub A v sub A over m sub B, and that's squared. So we know that. Now what we need to do is solve for basically this. So we know that if we if we put K sub A over, so 1/2 m A v A squared over 1/2 m B times m A v A over m B squared. First of all, let's just cancel those. So just get rid of those. And then we can rearrange everything in here, and so let's distribute this squared. That'll help us a lot. In fact, let's go back a little bit. I've kind of got ahead of myself. So let's come over here. We'll get K sub B equals 1/2 mb times m A squared v A squared over m B squared. So all I did was distribute that squared. And then when we do that, we can cancel this with this. And so then we end up with KB equals 1/2 m A squared m sub B times v A squared. Now let's go back to what I did before. So like I said, it was just easier to do in here. But we're looking for K sub A over K sub B. So we get 1/2 MA V sub A squared all over 1/2 M sub A squared MB times V sub A squared. Now, like I did before, we can just cancel out these halves, so that's nice, those are gone. But we can also cancel, now that we've distributed everything, now we can cancel out these V sub A squareds. And then we can cancel out this M sub A with one of these ones. So we end up with, I'll just rewrite this, we end up with 1 over M sub A over M sub B. When we flip and multiply, we end up that KA over KB equals MB over MA, which is exactly what we were looking for from the given problem. So since we've proved that, we know for a fact that those two values are equal. So just as an overview, we used conservation of momentum to find the v sub b in terms of the other variables. And then part B wanted us to use the kinetic energy equations to solve, or not really solve, but to kind of verify that this statement is correct, which we found out that it is. So anyway, I hope you learned something, and I hope you enjoyed it, and I'll see you in the next video. Thanks for watching.